Well, hey everybody, Mr. Reeves back with you again today, and today we're doing some extra practice with solving one-step and two-step inequalities. So in this video, I'm just going to be working through some of these problems that I have assigned with you. All right, so without further ado, let's just go ahead and dive in. Remember, solving an inequality is trying to find all the values for the variable that make that inequality true. And to do that, we use inverse operations. Well, when there's only one step, you only have to use one inverse operation. All right, for example, on this first one, we have a number added to 13 or 13 added to a number and it's less than 20. Well, we want to do the inverse of that 13 that they added. So we're going to go ahead and subtract 13 from each side. Well, the adding in 13 and subtracting 13 cancel each other out. And I get n is less than, well, 20 minus 13 is 7. And since we did not multiply or divide by a negative number, we do not have to reverse the inequality sign. Now you will be asked to do some matching on this assignment. So you go over here. These are the answers for 1 through 8. We just did number 1. I'm looking for this answer, and there it is, E. All right, so the answer to this first one would be E if you were filling out the Google form. All right. How about we take a look at one where it has a different operation? How about multiplication? 9 times n is greater than or equal to 66.6. All right. The inverse of multiplying is dividing. So I'm going to go ahead and divide both sides by 9. And I'm going to get n is greater than or equal to 66.6 divided by 9. Now I'd like to remind you it is perfectly acceptable for you to use a calculator and strongly encouraged for many of the problems. 66 divided by 9 is equal to 7.4. And again, since we divided by a positive number and not a negative number, we do not need to reverse the inequality sign. And the great thing about these matching ones is if it's there, you could be fairly confident you got it correct. Now be careful. This one says less than or equal to. This one says greater than or equal to. So this one would be the letter I. The letter I. Okay. All right. How about a division problem? 8.3 is greater than n over 10. Well, the inverse of dividing by 10 would be multiplying by 10. So I'm going to multiply both sides by 10 here. All right, well that 10 and that 10, they're inverse operations, multiplying and dividing by 10. So that gives me n, and then here was the greater than symbol. 10 times 8.3, hopefully you don't need a calculator for that one. Multiplying by 10 simply moves the decimal one place over. And we get 83 is greater than n. 83 is greater than n. When I look over here, do you see how these all start with n's? Mine doesn't, so be careful. This doesn't say n is greater than 83. It says 83 is greater than n. So we're going to flip that around, and we're going to write it the other way. All right? If 83 is bigger than all the n values, when you flip that around, what do you get? You get that all of the n values are smaller than 83. Do you see how that works? If 83 is bigger than all the n values, so if we were on a number line, okay, here's 83, and all of the n values would be smaller. Whoops, just missed that, sorry. All of the smaller, those would be smaller than that. All right, so n is smaller than 83. N is less than 83. So that's what we're looking for there. And so when we take a look here, it would be this one right here, which does not have a letter on it. So I'm just going to put a colored in circle. There we go, because that's what it matches up with, that one right there. Okay, there's a reason for that, but we're not going to worry about that. All right, so we solved an addition inequality where we subtract to get the answer. We solved a multiplication inequality where we divided to get the answer. We solved a division inequality where we multiplied to get the answer. We should solve a subtraction inequality where we add to get the answer. All right, how about number 7? We'll just go back one here. All right, a number minus 52. All right, 16 is less than that. So I'm going to add 52 to both sides. All right, when I do that, again, the subtract 52 and the add 52 cancel each other out. Well, 16 plus 52, that's going to turn out to be 68, is less than n. But again, just like last time, since all of our answers start with n, we need to flip this inequality around. If 68 is smaller than all of the answers, then all of the answers or all of the solutions must be bigger than 68. See how that works? All right. Move everything around and flip the sign. So n becomes first, 68 becomes last, and the less than changes to a greater than. N is greater than 68. Right there is H. Okay. All right. So there I've done for you one of each type of problem. Use the inverse operation and make sure you pay close attention if that variable turns out to be on the right side that you flip the whole inequality around. All right, let's go ahead and look at a couple word problems down towards the bottom here. See what we have going on. Write and solve an inequality for the verbal statement. Let x be the unknown number. All right, so here we go. X plus 2.7 is greater than or equal to 9.4. So if I wrote that out, it'd be x plus 2.7, just like it says, greater than or equal to 9.4. Of course, then to solve that, we would subtract 2.7 from each side. I'm going to let you do that one on your own. What about this one? 12.5 is less than or equal to the quotient of x and 8. So 12.5 less than or equal to. Now remember, quotient, we have sum, which means add, difference, which means subtract, product, which means multiply. Quotient means the answer to a division problem, the quotient of x and 8. All right. Now again, on this one, we would have to multiply both sides by 8, and then this one would be one we'd have to flip over. If we wanted to switch it now before we solved it, if 12.5 is less than or equal to x over 8, then x over 8 must be what? Greater than or equal to 12.5. So you could actually switch the order around before you solve it, or you can switch the order around when you get the answer. All right. 7/10 of a number, 0.7. 7/10 of a number is less than 8.4. Oh, now it's 7/10 of a number. All right, so that tells us it's 7/10 times. Remember, we talked about this earlier this year. Of indicates multiplication. 7/10 of a number. It says to let x represent the unknown number. So 7/10 times x is less than 8.4. All right, and again, to solve that, what would we do? The inverse of multiplying by 7/10 would be dividing by 7/10. All right, what about number 23? This is the last one we're going to do on this worksheet. A freight elevator is being loaded with identical 76-pound boxes. The elevator can carry no more than 2,000 pounds. How many boxes can be loaded on the elevator? So we've got this elevator and they're loading up boxes, all right? And these boxes all are 76 pounds, okay? We don't know how many there are, but it can carry no more than 2,000 pounds. Well, if it can carry no more than 2,000 pounds, it could carry 2,000 pounds, but it cannot carry more than 2,000 pounds. No, so what can it be? Less than or equal to. And since we don't know how many there are x of those boxes. All right, so our inequality would be 76 pounds times x, however many there are, must be less than or equal to 2,000. And then, of course, we would divide by 76. Now, keep in mind, you're not going to have part of a box. All right, so say we got, I don't know, 7.2 boxes or something like that. All right, then we would round down to 7 boxes. Okay, you're going to round down no matter what because you're not going to have part of a box. Okay, all right, so that is solving one-step inequalities and some word problems with one-step inequalities. All right, I think I'm going to end this video here. In my next video, we're going to do a review of solving two-step inequalities. All right, until next time, have a great day. Bye.